First off, I would like to introduce today's participants. On the call, we have myself, Rob Rasnick, who is the Cintoo Sales Director of North America. Then we have Dominique Poulican, who is CEO of Cintoo US. And finally, we have David Drefts, who is the Cintoo Services Director in North America. So now let's discuss today's agenda. First, I will discuss some industry challenges and give a high-level introduction to Cintoo Cloud and how it solves these issues. Next, I will turn it over to Dominique Poulican, as he will give an in-product demonstration of key features in Cintoo Cloud. Lastly, we will turn it over to David Drefts, who will give an in-product demonstration of some of the key workflows that Cintoo Cloud leverages. And finally, we will close with a Q&A session to answer those questions that came during the presentation. So now, let's get on with the show. Cintoo Cloud is at the convergence of digital twins and reality capture. Quite simply, a digital twin is a virtual model of a process, product, or service. Think of a digital twin as a bridge between the physical and digital world. It applies to architecture, engineering, and construction, oil and gas, utility, and the energy industries, as well as manufacturing through the concept of digital factories. It also applies to vertical infrastructure such as bridges, tunnels, and structures that support these facilities. Digital twins are becoming a business imperative, covering the entire life cycle of an asset or process and forming the foundation for connected processes and services. To digitize the real world, people use terrestrial laser scanners to get accurate as-built conditions. Those devices, built by companies such as Leica, Trimble, Faro, Topcon, or ZNF, become cheaper and cheaper and much easier to use. They produce a very accurate point cloud made of millions of 3D dots in space, with an accuracy of 1 to 5 millimeters, with RGB information included as well. The goal of using terrestrial laser scans for digital twins is to get the most accurate as-built conditions. This data can be used for several cases in each industry. In architecture, engineering, and construction, it's about virtual coordination, project reviews, issue tracking, and monitoring progress, but it is also used to convert the scan data into a BIM model. Generally speaking, it's about making sure that the project is on time, on budget, and on schedule. In the oil and gas or manufacturing spaces, it is all about maintenance and repair simulations, or planning new layouts or retrofits. It's about reducing operational downtime while allowing teams to make informed decisions. So what are the problems we're trying to solve? The number one problem is the fact that the size of the data is gigantic. Each scanning position will generate between 250 megabytes to 2 gigabytes of data. So imagine the amount of data created to scan a facility with 100 or even 1,000 scans. So for the people that need to consume this data in their daily job, in the field, or in the office, there is no other way today than to ship a physical device, such as a hard disk, to these individuals. The result is that this data only supports a very desktop-centric workflow that creates data silos. Not only silos within companies, but also silos with subcontractors. The second problem to solve is the fact that reality data is difficult to interpret. The panoramic image coming from the device can be over or underexposed, or even very dark, making it very difficult to see anything. The point cloud itself is very ambiguous data. Since you see through the dots, you are not sure to pick up the correct dot to perform even a simple measurement. So once again, it is still a very specialized technology for experts. Now we will show you how Cintoo Cloud resolves these problems. The core technology behind Cintoo Cloud is the capability to turn each point cloud from each scan position into a very high-resolution mesh, including multiple levels of detail using our core wavelet compression technology. This compression allows us to stream very fast in a web browser. People refer to us as a Netflix of 3D data for this very reason. By performing this point cloud to mesh transformation, we will also make the data much smaller. We will reduce the size of the data by a ratio of 10 to 40 times. Let's say you start a project with 100 gigabytes of source point cloud data. Your upload to the cloud after transformation is only 1 to 5 gigabytes of data. The good news is that the inverse transformation of this compressed data is also possible. This technology retains the accuracy of the source sensor and the structure of the project. So we can bring back the mesh in its source point cloud format and retrieve back your 100 gigabytes of data. This is very unique to this technology. This is a typical panoramic view from a laser scan. We have transformed this into a 3D mesh, and if you remove the color from the mesh, you will see what has been captured by the laser in the form of a very highly accurate surface mesh. Look at all the detail that is now revealed. When you move to the next scan position, you now see the streaming of the high resolution mesh and level of detail. Look at the quality of the mesh. This technology is all about revealing details in your laser scan that you have probably never seen before. This technology is embedded into a platform called Cintoo Cloud. The goal of Cintoo Cloud is to make your laser scans fully cloud compatible, and by becoming cloud compatible, they become shareable, distributable, viewable, and you can enrich this data with notes, measurements, etc. This enables a collaborative environment that supports BIM workflows. The goal is to have Cintoo Cloud cover all the use cases for terrestrial laser scanning in the digital industry by being a device-agnostic platform where you can manage your data and view your data, organize your scans, collaborate and share, and add measurements and annotations. By having this data in the cloud, you can extract meaningful information leveraging cloud computing and produce reports and experiences. Cintoo Cloud lives in an ecosystem where we have to connect the field work to the office work. Today we use mostly Autodesk workflows. Cintoo Cloud also has the ability to connect to other platforms, such as Autodesk BIM 360. The goal here is to make sure that the BIM model and the scan data can be used together to extract meaningful information. Cintoo Cloud runs on either Microsoft, Azure, or Amazon Web Services, and in some cases, the user has the option to select a regional data center to meet project requirements. In terms of workflow, we take the data after it has been registered in a software, such as Autodesk Recap, Ferrocene, or like a Cyclone. We take the data as a structured project. We need to have the vantage points, the panoramic images, and the depth maps. We then use a software called Cintoo Connect, which is a Windows application that will be run from the web app, where we will perform the point cloud to mesh locally on the client's computer. The transformed data will then be transferred automatically to your project in Cintoo Cloud. Now that this data is loaded to the cloud, everything streamed in the browser will be mesh-based. When we need to distribute back the data in its original form, we will do the inverse transformation of mesh to point cloud locally on the client's computer. We can now export unified mesh in OBJ, STL, and FBX formats for consumption in other applications. We can also produce reports, analytics, measurements, and annotations, as well as create hyperlinks to a shared viewer for distribution to those not on the project team. When we connect to BIM 360, we can pull IFC, Revit, Navisworks, and 3D DWG models into our project. The goal is to overlay the model with the scan data to detect issues. Those issues can be pushed back to BIM 360 as a BCF or BIM collaboration format file for distribution in your issue tracking applications. Cintoo Cloud is all about streaming high-resolution meshes in a web browser. We work on laptops and desktops, and we now stream to iOS and tablets. We also stream on VR headsets such as the HTC Vive and Oculus Rift and Rift S using WebVR as our toolset. Cintoo Cloud is a collaborative platform for everyone. We have a very simple UI with no plugin required that can be used with industry specialists such as surveyors, engineers, architects, etc., but also with other stakeholders that may not have any experience with laser scans or 3D data. Our platform has been on the market for 1 year now, and as of January 2020, our clients have uploaded over 300,000 scans, and it is being used by general contractors, manufacturers, and process and power customers. And now I would like to turn it over to Dominique Poulican, who will discuss some of the key features in Cintoo Cloud.
Hi, Dominic speaking now. Thank you very much, Rob, for your introduction. The first thing I'd like to highlight in this webinar is the fact that Cintoo Cloud is now compatible with Edge, Microsoft Edge. So if you want to try that, very easy. You just go to Edge and you just type Microsoft Edge download, and then you go to this page, and then you can download the new Microsoft Edge. So give it a try. It's really interesting, and that's a new experience. But let me switch to Google Chrome now. So I will log in. Something I want to highlight is the fact that Cintoo Cloud. In Cintoo Cloud, we can incorporate your corporate SSO, single sign-on. Many customers have done that already. There is a small fee coming to it, but by having a corporate single sign-on, you're sure that Cintoo Cloud will comply with your with your login password policies. So that could be interesting for some of you. So I just log into Cintoo Cloud now. So in order to get SSO, please come back to us and send us an email at sales@cintoo.com. First thing I want to highlight also is that we have, of course, the dashboard here. You can now create groups of users. So when you go into your users directory, you have a new tab here, which is groups. So you click on groups, and you can add a new group. Give it test. With a name like test webinar. I create a new group. And then I will be able to invite as many people as I want, either by inviting one by one or by having multiple users at once. Okay. And then I take a very small group like Rob, Alex, and David from our team. So this is a new group here. This is a list of the group. Okay, so now I have in my groups, I have two groups, and I can see who's inside. So when I will invite people to my projects, I will be able to invite them as a group. And a group is a living entity. So every time you add or delete users to your group, that will be automatically updated in your projects as well. That could be really interesting when you have multiple people to invite. Always there's the same people or a big number of people. Creating a group can be very useful. There are other new stuff that I want to show you. First, in the admin tab, for those of you who have got the admin tab, you have now the possibility to add co-admins as well. So in case you are away on vacation, for example, or anything like that, you want to add another person in charge of the admin aspects. So please go on there and you can invite co-admins. Of course, we still have the possibility to define roles and permissions. You know, we have presets here like a BIM manager to a viewer, etc., that have certain permissions, certain rights to access the data. Basically, a BIM manager can do everything: upload, download data, view, annotate, measure, etc. A viewer only may have only the capability to view and add some measurements, and you can create your custom roles here as well. Let me now switch to my projects. So the first thing so this is my list of projects in my account, and I can view them as a thumbnail, as a list. This is the people that have been invited to each project here, or on a map as well. And you can zoom in and see what is the projects around. Let me go back to the thumbnail view. Here, what I will do, I will create a project. So when creating a project, I need to select the account, the plan, of course, give it a name, call it test webinar. Give a description eventually. You can geolocate your project anywhere you want. Let's put that in Atlanta. Then you can select the hosting option as well. So you let go the data go to the cloud, will be hosted on Amazon or AWS or Microsoft Azure, there will be duplication of the data using the CDN, which is a content delivery network, based on where your users will be. Or you may select to say, no, I want the data to stay in a given region or given data center. And then you select both the provider, being AWS or Azure, and you make sure that the data will always stay there. So let me use Amazon East Virginia here as an example of that. So I just create, and this can change for every project, of course. I created here the test webinar. There is nothing yet, but I will upload scans, models, and documents here. One of the first things you want to do once you've created your project is assign team members. So I will go into members. And now when I add member, I have the possibility to add either users individually or groups of users or new users based on the email. So when I go to groups of users, I can select the one I just created. And when I select this one, this is where I will assign these roles and permissions. So let's say this group will have a BIM manager type of role. Okay. Now let's go back to data in order to upload scans and organize this data. So in order to upload scans, you need to install, whoever is going to upload scans needs to install Cintoo Connect. Cintoo Connect is a Windows app that will run locally on the computer of the person that will load data. The same Cintoo Connect will be used to download data. So whoever needs to upload or download data from Cintoo Cloud needs to install Cintoo Connect. You just click here, that will start the download process of Cintoo Connect. And when it's downloaded, you can install it locally. Cintoo Connect will always be invoked from Cintoo Cloud. There is no way to run Cintoo Connect by itself. So in order to run Cintoo Connect, you just go here, so upload scans, or you can also start from here, prepare and upload. And what it does, it will invoke Cintoo Connect and will run Cintoo Connect locally. So Cintoo Connect is used to do this point cloud to mesh transformation. Sorry, which is the core technology provided by Cintoo to turn each scan into a very high resolution mesh that has multiple levels of details, compression technologies, and everything like that. So Cintoo Connect will start now. And there are a few new stuff in Cintoo Connect as well, which I want to highlight. So this is Cintoo Connect. This basically what you can do is select your input files. So we can read now FLS files, E57 files, and RCP files. So let me go for this small data set that has been provided to us by a friend of us in Brittany, France. And what you can do as well is select how many scans you will run in parallel. So if you have a multi-core machine, you may want to go up to 8 transformation in parallel. Here I'm using a very small laptop, so I will not go more than 2. And when I click on import, what happens now is that we are doing this locally on my machine. This point cloud to mesh transformation is happening. It takes about 1 minute for 10 million point scans. So it's pretty linear. So if you have like 40 million point scans, it take about 4 minutes. Most people will run it overnight. So interesting stuff here, new stuff. You may not upload right away. So you may be in a situation where you just survey a site, you are at the hotel, the Wi-Fi connection is not very good, but you still want to run this point cloud to mesh transformation locally. So you can do that. And then you will resume the upload later. So this is a possibility. Also, when you have to quit, because time is over and you need to quit, you can resume later. So I can say, yes, I want to resume later. So when I go back to the same work zone the next day, okay, and I say upload scans, it will ask me if I want to resume the previous task, okay? So let's say you have 100 or 200 scans to upload, and it takes maybe a few hours. Either you run it overnight, which is the best way to go, or you want to stop Cintoo Connect before you leave the office. You can come back to where you started. You say, okay, it's previous import found. Do you want to resume or discard it? So I say resume, and then it's starting exactly from where you let it go the day before. So I have paused a little bit here on coming back to this after 2 minutes. I already have 2 scans uploaded, and 2 more are being converted as we speak. So if I go back to my data view now, I can see I have 2 scans already uploaded. Okay, which I can view in the data view. This is a typical panoramic view from the scan. This is a BLK 360 data. Or I can view, of course, in the 3D space, and then I will see the same data as a very high resolution mesh in my 3D view, which is the beauty of this technology. So this is a 3D navigation. So I can start by, this is typically what you would see, the 2D panoramic image, okay, of this laser scan. But switching to RGB, I basically see the same, except that this is a 3D model now, okay? And if I remove the color from it, I go to the surface mode, I will clearly see what has been captured by the laser beam. And that's really where the technology shines, because if you need to do like accurate measurements on annotations, you may not see a lot of information from the 3D RGB here, but if you go to the surface mode, you really see everything in details. So making like a measurement here, for example, between these 2 points is becoming very easy to do because you know exactly which points you are picking. Okay, or the same with annotations, and you can create as many annotations as you want. Clicking on add annotation here, I click a 3D point in space. An annotation can be a note, a private note, or an issue. If it's an issue, I need to add a text, of course, to be discussed. I can add a severity parameter. I can add a due date. Let's say this has to be fixed by next week. I can add text, photo, video, URL. You can link that to a database. You can also upload pictures now, pictures that you can take from your disk. And now we have the possibility to see very high resolution picture as well. Let me add this picture to it. Okay, so this is a big picture. I need also, since it's an issue, I need to assign it to a team member. So let me add it, assign it to myself. And now I create the annotation. Okay, now a big picture is being uploaded to the annotation as well. And we have the capability to view this high resolution picture. This is a new feature as well. So when I click back on this annotation here, that comes with my 3D points. If I click on this picture now, I will be able to view this high resolution picture. In the meantime, more scans have been uploaded through Cintoo Connect. So if I go back to the data view, I see that now I have 4 scans. And again until I guess I have 16 scans here will be uploaded. Let me now switch to another project that has been already uploaded. So going back to my projects, I will select another one like this train station, for example. This one has 56 scans uploaded. These are Leica files, Faro, and DNF data. First thing I would like to show you is a 3D view. This is where we stream all those high resolution meshes in the browser. You see how fast we can stream. This is my 3D view, RGB. There are various, everything we are looking at now is mesh-based. Okay, so we stream very fast, high-resolution meshes. There are various shaders you can apply. So this is a 3D RGB, but you can also see that in X-ray vision mode. Okay, so you see the inside of this building. You see all the scan locations here. You can also view that as a height map where you can display You can colorize the mesh based on the z-axis and do some analysis this way. You can also have the surface mode. Let me come back to the 3D RGB and let me switch to the scan position. This is where really you will see the impressive technology. So what you see typically is this kind of view. And again, in most cases, you will see these 2D panoramic views. Okay, so this is a 2D panoramic view of this exact scan position. Now, when I switch to the 3D RGB, I'll see basically the same. But when I remove the color, go to the surface mode, you really see every single detail that has been captured by the laser beam. So for the people on the call today that can see the platform for the first time, this is really where the mesh-based technology will reveal every single detail that has been captured by the laser beam, making your analysis and interpretation much easier to do. Okay, so when you'll see that when I move to the next scan position, what's happening now is that we are streaming very fast these high resolution meshes until we get the finest level of detail. Okay, and you would use the surface mode typically to do your measurements and annotations. You can, of course, go back, get out from the scan position and go to the 3D navigation mode, in which case you can navigate freely in the scans. And what you see here is not a point cloud. These are all the vertices from all the meshes coming from all the scans. Something you want to take a look at is this overview map. The overview map is a set of orthographic views of your site, starting by the top view. And this is all the scans here. Okay. And here typically, so you can view that this is a top view, but you have all these axes available. People would use the X-ray vision mode here in most cases. So you clearly see where the scans are located. So again, this is a top view, but this is a left view of your project. And you can use this type of view to do many things. The first one you may want to create, the first thing you may want to do is create what we call work zone. The work zones are a way to organize your scans in various regions. So for example, let me say those 5 scans need to be together in a single work zone called, let's say, call it interior. So what I will do, many ways to do that. Either I select those 4 scans like this using the rectangle selection tool. I go into the work zone tab and I say add work zone and I call it interior. This one exists already, so create work zone. So by doing this, I created a subfolder here. You see it on the left here, called interior, that has 5 scans assigned to it. So if I click on this interior work zone, I will only display those 5 scans, okay, either in 2D or in 3D space. If I go to 3D, all the same. And you'll see that here, since everything we do is mesh-based, I have a very interesting feature which we call backface culling in 3D space. By clicking on backface culling here, you see we don't display the faces that are not oriented toward the camera. So from any angle, looking at inside this building, you will always see the inside. You don't need to clip data to see inside a building. But let me come back to the overview map. So I go back to the root of the project with the 56 scans inside. And I have another feature I want to show you here, the possibility to crop data as well. So again, going back to my X-ray vision mode here, removing this timeline, going to the front view, for example. What I can do is use my crop tool here to create sections on the slices of points, in fact. So along the z-axis, for example, I can create a section of my point cloud. You see, I can adjust this section where I want. If I look at that from the top view, you will see that it's looking at your project like you would do with an MRI of your building. Okay, so I can select the best possible crop here. Let's say this is a crop I need for, let's say, creating a 2D floor plan. I add it to my list of crops. So this will be crop 53 now. I can see it in the 3D view as well. So if I go to the 3D view, go back to my list of crops, click on crop 53. This is a crop I created in my 2D orthographic views, but here this is the same in the 3D space. Go to the surface mode, for example, and then I can still adjust this crop as much as I want. So I can adjust it, still do the best slice needed for my job. Once I have created this slice, I have two ways to use it. The first one is to export it back as a point cloud, will be a unified point cloud in this case in RCP, RCS format, or I can create as well what we call a unified mesh. So creating a single mesh from all those meshes in a OBJ, STL, or FBX format that you will be able to download. And I will leave this part of the demo to my colleague David later. You can create meshes, unified meshes from slices, but also you can isolate equipment or this kind of stuff and use this tool to generate your unified meshes. Two things more I want to show you in this webinar. The first one is how to share this project. So I already showed you how to invite team members. This is the first way to share. All those members will need to log in and password to Cintoo Cloud, and they will be part of the project. They can enrich the project with metadata, and they're becoming team members. Another way to share is to go to the sharing option here. You may want to have people see the project, but not being a team member by having a simple URL. So we have various options here when you create a sharing URL. The first one is that do you require the person to be part of the member, yes or no? You may add a password. You may have an expiration date. You may want to share all the metadata or not. Okay, and you may even include your company logo in this shared viewer, and then you generate a shared URL. Okay, you can even have a QR code coming with it, and then you can edit and copy this URL and embed that into as an iframe into your website or send that by email. And the people will be able to let me show you here. Copy this in another window. People will be able to see then access the project as a shared viewer. Okay, so they will have this kind of experience here. They will be natively in the scan position, and they can switch to the surface mode, but they can also go into 3D navigation mode, and they will be able to see the project. So this is a very interesting way to share your projects with other people than people that are team members. Another thing I want to show you is that we can generate reports, okay? Two kinds of reports. The first one is about all the activities from all your users, like measurements, notes, private notes, etc. You click on here, export as PDF, and that will very quickly generate a PDF file containing all those measurements, annotations, whatever you put in the activities. So here you see on the bottom left, the report has been generated. I'm just clicking on it now. It's a PDF report, which has this, so you see the report now, you see all the activities that have been going on in your project, like this, all the issues that have been created. And what is interesting is you click on this here, like number 2 to be checked. I have a direct link to this issue in the project. So you can go from the PDF to the project, and you will be in the exact same viewing condition that was used when creating this issue. Another interesting report is a BCF file. So issues can be exported as BCF file. BCF means BIM collaboration format, is a commonly supported format by many issue tracking solutions like BIMtrack or BIM 360 or even Revit and Navisworks can read BCF files. So generating a BCF file here, which you can see here, is a zip file with everything needed to use this data into your best issue, your issue tracking solution of choice. One last thing I want to show you is in the data view, each scan has got its own URL as well. Not all users of Cintoo Cloud are aware of this one, but for example, each scan Like this first one, train station one, has got its own URL that you can use to share the scan only, or you can also have a QR code coming with it. And if you select various scans like these 3 scans here, I can then export a CSV file, and an Excel file will be generated that contains all the information corresponding to those 3 scans, including the shared URL that you can copy paste in another database management solution, for example. Thank you very much for your attention. I leave it to the rest of the team now for more demos.
Thank you, Dominique. And now I would like to introduce David Dreffs, who will discuss some of our integrated workflows using Cintoo Cloud.
Hi everyone, Dave Dreffs here. I'm going to talk about a few of our tools that we have, including meshing, exporting, comparison, and alignment. So I do want to start out right here in our data view. So data view houses all of our information such as laser scans, models, meshes, PDFs, DWs, anything that you want to add into here to enrich your product. Now, I like to start off by separating things out by either the date in which you want to organize it, scans, models. In this case, we have a small project, 25 scans. So right off the bat, I know we're all in one area. So I have just scans, models, and meshes. And these things are all drag and drop. So if I wanted to just grab something, drag it into another location, I can drag and drop it into that location. Purpose of organizing is it gets a little crazy. So when you're ready to bring them down, you can pull them down all together, or you can just download them right here. So one at a time. And as you download it, it'll just drop it down here. It comes down as a zip file. In this case, I called it issue 1 as an FBX file. Models work the same way. In this folder here, I have a model, but if I want to pull more models in, I can just come to here and say upload models, attach to BIM 360, or pull it from my local hard disk, either or. Puts it right into that folder, keeps it nice and organized. You can also download this model too, so it's another way to share information with people. The scans themselves, different ways to pull these out. You can either export them out one at a time, or you can export them all out using our Cintoo Connect tool. Export them out as scan files, or you can just export a CSV file out that gives you the list of the scans and some information about them. Try not to delete your data, but if you need to, you can pull these out. And that is a permission that we can set on when we set our members. So jumping into this hierarchy here, if I click on scans and view it like this, and say 3D view, it'll start to load, and you can see this is just our laser scan data. If I click on models and I'm in our 3D view, you can see it just loads our 3D model in. And if I go to the top level in the 3D view or the overview, you'll see that it'll bring both of them in together. So this is the purpose of creating folders here. This will be able to organize it in a way where you can view what you need to view at any certain time, turn things on or off, and again you can just pull this work zone open and turn on or off your models or your scans and just have on what you need. Alright, so moving on here, we have some annotation tools that are great. These annotation tools help us define issues, enrich our data by adding information. So if I pull into here and I want to label this cabinet, I could say here's an annotation, add an annotation, click where I want it to add, call it electrical box, box 1, 2, 3, and we can add in pictures, hyperlinks, videos, lots of information, right? So a note is just some information, and that goes to everybody that's on your project. A private note is just for you, and an issue is a whole nother thing. So if I change this over to an issue, I can give it a severity, I can give it a due date saying this issue's got to be fixed by next week, and then we can give it some information. This electrical panel needs to be moved 2 feet, right? I can assign it to Alex because he does a little bit of work for us, and hit validate, make sure that he's still in our project, and hit create annotation. Now it sends me an email letting me know that I created an issue. It also sends Alex an email that lets him know he's got some work to do. And I can log in anytime and see in red where there's still an issue. It pulls it up, I created it, and Alex will jump in and hit resolved at any point, or he can create a comment that says, you know, hey, I can't move it for this particular reason. So just a way to communicate back and forth. So moving on to our crops. So John talked about crops a little bit earlier. Now we can use our crops for several different reasons, just for visualization, for defining issues. So if I can see here, it really brings it down quite a bit, so it's not so crazy, everything else that's in there. We can update our crops. You can see that with a model in here, it also crops our model too, which is great. If I want to create this new one, since I did update this like that, I can say add, and it creates a new one for us while maintaining our existing one. So these are great for presentation wise. I can click through here very quickly if I have a bunch of crops, as well as for when you're not used to using this tool. You can set them up ahead of time, so having one person in your group that's really good at this, set it up for the other people, so these crops will be available for everybody that are in the project. The next use for the crop list is doing your export. So when I want to export out, say, a point cloud, I click export, open Cintoo Connect. I can export it out as a unified RCS file, so one single RCS file, an unstructured RCP. So it creates a recap project, and then it also exports out an RCS file for each scan that's contributing to that model. And then we can set our spacing. If you use recap, you're used to seeing this. That's our slider. It decimates the model, puts a point every millimeter or every 5 or whatever you set it at. You can give it a name and tell it where to go. And just hit export. Now, this takes a little bit different time from importing. The exporting usually takes around 10 seconds per scan. So if you have 25 contributing scans, what it's doing is pulling each scan down at one given time. It uncompresses it from a mesh, converts it back into a point cloud. It takes all the information that you're used to seeing and bringing it back together. So pull that down. And you can see it here. Open it right up in recap. We've got our point cloud right back up. And we've got our original point cloud data set. Alright, the next use is creating a mesh. This 3D meshing has been really exciting for us. We've got a great engine built into this platform. We use online computing to create this high resolution mesh. We can give it a name here. We can set our density. So please remember that this is a mesh of a point cloud, so we're going to have a lot of polygons. So if you go all the way down to 2 millimeter resolution, that's going to be a really large mesh, very high detail. So setting your mesh at its proper resolution is very important. So we'll take this one, we'll say 0.5 centimeter. 0.5 centimeter to me I know that I'm going to put a point every 1/5 of an inch, and it's going to be able to give me a detail on conduit or columns or things like that. It also tells you roughly how many points or triangles will be in there, and you can set your files. So FBX, OBJ, and STL. FBX files used in Navisworks or any Autodesk product, you know that that's an Autodesk extension. OBJs are used in a wide variety of platforms such as Inventor, 3ds Max, STLs. If you're trying to get into any Siemens products, that's the way to go. We'll have Ply coming soon, as well as a few other formats that we get requests from. So here, let's say FBX. I like to put the extension in here, and then also put the density, and hit create. So it lets you know, hey, we're going to do some work. It's going to put it in our folder as soon as it's done, and then we can download it as we need to. So we can say OK, go in our mesh files. I did this a little bit earlier. The mesh file usually takes somewhere in the range of 15 minutes for something small to 2 hours if it's massive. It really depends on how many scans you have contributing to it. Now, the number of scans we do limit currently to 100 scans per mesh. So if you're trying to create a mesh, try and keep it within these folders, 100 scans in each. The project itself, just divide it up and pull it apart. So here's our 5mm. We can come in here and just say download. It'll pull it down, put it into our downloads folder. That comes down as a zip file. So this file itself, I already pulled it in. Here it is. I just grabbed this file, brought it right into Recap Photo. Pulls in all types of files. Gives us a nice high quality 5mm spacing mesh file. And if we wanted to bring it down to 2 to get a little more detail, you can see that it's nice and high quality. We really do a great job at our photo texturing. On every time that we create a mesh, we re-photo texture the file from the laser scans. That's one of the parts why we have structured files. We want to maintain those high resolution photos that come across so we can retexture our image. So if we were to do a floor setting that had a bunch of scribe lines on it, you can put that at 10 centimeters and it would look the exact same as this, only because we re-photo texture that floor. You can take that file, bring it into Revit, nice and easy to move. Bring it into Inventor, bring it into Navisworks. A lot of different use cases for you guys to come up with. I know we've got a lot of different softwares out there. We're just trying to create common platforms where we can be able to bring it as you need into different products. All right, so let's move on to the next tool. So next is the manual alignment tool. This is a great tool for people who aren't great at locating their models or geolocating their point clouds. Also, in case you need to move one, so what we do is we open our manual alignment tool. We pick what we're going to move. So I'm going to move my scans, and I'm going to move it in reference to my models, which means that my model will not move, but my scans will move. And we can swap those two if we need to. This here, it's a little highlighter that just turns on or off which reference that you have. Just a way to give you some different visualization. I like to pick a pivot point. In this case, I'm going to pivot around this point here in case I need to do any rotation. And in here, I can either use the up or the down arrows to slide, or I can just put the roller ball right in here and slide it back and forth. Now, we need to move it in the Y direction. Looks like about 1 foot exactly. So we're set in feet right there. You can see that moved right in, and I'll slide it back and forth to show you. And I'll just accept it. If we need to do any rotation here, we can show here, we'll rotate around that direction. All right, I'm gonna put 0. All right. Now, just to check it out, this here, nothing is permanent until you hit apply. And once you do hit apply, it will update the entire point cloud itself. So when you do download it, it'll download in this new location. Okay, so that's our move tool. Next here is our comparison tool. So we had an issue with this column here, wasn't in the right place. When I do want to do some comparisons, I'm going to compare my scans to my models. And again, we can swap those back and forth. Turn on our visual diff tool, and it'll highlight the mesh to show you the deviation between the two in either a flat mode or a soft ramp mode. The ramp mode here, we can adjust up or down for different levels of detail to show how far we are still off. And to give you one step further, down here we can see that there's still an issue. We can either swap the two, and it'll color code the model, or go back to the mesh. We turn on our visual diff tool, and we can see both of them lit back up. Slide one way, it turns just the mesh on, all the way other, just the model, or back and forth to see where our issue still lies. So heat maps are great, gives you a deviation, but there are still, you need to see which direction it's off. Alright, so those are the tools that I'm going to use today. Happy to show you more in the next session that we have.